Can everybody hear me all right? Sounds good? Awesome, awesome. Well, good morning, everyone. And thank you for coming to my talk today. I hope you're all having a great NZGDC this year. I'm honored to be back. I spoke last year, but I always love coming to these events and being able to share with you and give back to the industry and the community. So I really appreciate you being here. I've been told to stay close to the microphone, but I am a natural pacer when I talk. So if I end up at the back of the room, someone just yank me back, all right? So a little bit about me. Same jumper. So my name is David Delgado. I've been in the industry for about 7 years now. And in that time, I've had the privilege of working at some immensely talented studios such as Pickpock, shout out Pickpock, Mytona as well. And the current place I call home, which is Fat Loot Studios. And in my role as a technical lead, I work with some very talented people, some of which are in this room right now. So shout out to Fat Loot guys. On a real cool game, and also a lot of the peripheral services that come with that. So as I said, I'm very passionate about software development, about architecture, and about design principles. And last year, if you came to my talk, I talked about trash code and when you should do that, right? Which is, spoilers, not very often. So today I bring you the other side of that coin in hopes that we can empower each other to create better games in a better way. So to start off, I wanted to get an idea of who in this room considers themselves an artist. Can I get a show of hands? Yeah? About 5 of you? Cool. I've seen your Gardic phone drawings, don't lie to me. All right. Well, today I want to share the idea with you that as developers, we can be far more creative, thought-evoking, and artistic than we actually give ourselves credit for. But how can something as logical and systematic as code be artistic? Where's the beauty amongst the canvas of zeros and ones? And what kind of masterpiece could come from the brushstrokes of our keyboard? Today, I want to touch on not only how we can shift our perspective and bring new meaning to the things that we do, but also why we might want to do this in the first place. But to enable myself to do that, I first need to go back to the basics and attempt to answer the question, what is art? So, from cave drawings and hieroglyphics, all the way to movies, games, and NFTs, the concept of art seems to be ever evolving and relatively difficult to define. And yet their presence in our lives is ever increasing, right? Art itself predates written language, and despite generations after generations of change and development, our natural instinct to create has meant that art has been with us for as long as we can trace. If you look at art in the dictionary, it is defined as the expression or application of human creative skill and imagination. And the word art is derived from the Latin word ars, yep, you heard that correctly, ars, and which originally meant skill or craft. Now, these meanings are still present in other English words that we use today, such as artifact, something made out of human skill, and artisan, a person skilled at making things. The meaning of art and artist, though, are not so straightforward. You know, we know that art involves more than just skilled craftsmanship, so then what exactly distinguishes a work of art from an artifact or an artist from an artisan? Well, when we ask this question, many of you will probably answer beauty, right? And you're right, a lot of art is visually striking. In the 18th, 19th, and early 20th century, aesthetics took a key part in the arts. But over the past century, however, art has evolved radically. And today we understand beauty as subjective, right? It's a cultural construct that varies across time and space. So while a lot of art continues to be aesthetic, beauty itself is not considered an essential attribute of art. So for a moment, you come on a journey with me and I asked you to close your eyes and picture art in your mind, right? It's probable that one of the images that come to mind first is perhaps something like this, right? Your traditional art. Or maybe your game developer brain switches on and you start thinking about the creative process that it takes to create the characters that we interact with or the worlds that we play in. But so far, art is hand-drawn. It is seen, but not touched. And if you recall, our definition of art didn't confine art to only the visual representations. Because after all, that's not all that art is it? If we expand our vision a little more, we start to picture the art that we can touch and feel, art that gives us perspective as we walk around it. Pieces such as sculptures and monuments, everything from the statue of David by Michelangelo to our very own hand-painted Warhammer 40k figurines. But then again, that's not all that art is it? Now we zoom out a little more, right? And we start to think about the stories that we can tell through taste and smell. The journey that our taste buds can go on when we taste a particular meal. Whether it's introducing our palates to something new when we eat at an extravagant restaurant, or the sensation of time travel that we get when we catch a scent of a meal that we grew up eating. But once again, that's not all that art is it? What about the art that unites people from all around the globe? Regardless of their country or their language, it has the power to make us dance, to make us cry, to make us smile, and all from the differently pitched frequencies composed in a rhythmical manner. Whether it is the structured army of musicians in an orchestra steered by the conductor, the ongoingly tweaked melody of by a producer in their studio, or a party of street musicians together to bring smiles to bypassers, music, the art for our ears, is a key component in our lives. I don't know if you get what I'm getting at here, but we're trying to define art, but art is not confined to things that we can see or touch or feel or hear or smell, right? And so if the answer is not in the what, then which is the common variable that brings all of these different crafts into the category, into the umbrella that we so call art? I guess what I'm trying to say is, what's the difference between laying some colorful substance on a piece of cotton fabric and creating the Mona Lisa? The work that for 500 years and to this day is considered one of the most valuable pieces of art ever created. Or what's the difference between the meal placed before you at the local McDonald's and the one that you'll be served at one of the most prestigious restaurants in the world, such as 11 Madison Park? Or yet again, what's the difference between a lecture given to you by an unenthusiastic university professor and the history-making cry to his country by Martin Luther King, where he said, "I have a dream that my 4 little children will one day live in a nation where they will not be judged by the color of their skin, but by the content of their character." Beautiful, right? To be honest with you, those questions aren't particularly easy to answer, but there are common denominators across all of these crafts which clearly separate the mediocre from the masterpiece. The first one is, each one of these art forms, the artist in each one of these art forms, the artist has put a significant amount of thought into what they're creating. They ask themselves, what do I want to create, and how do I create it well? They also don't just build, but rather they build with intentionality. They are equipped with a thorough understanding of what emotions they want to invoke and how do they convey and present themselves. They're thinking one step ahead about the outcome. And last, but certainly not least, the artist is fueled with a passion for their craft. They have a clear understanding of why they do what they do. And that gives them the resolve and the persistence to keep going in times of trial and tribulations. So whilst we might struggle to specifically define art itself, we're heading down the right track, right? And I think it's pretty safe to say that in a general sense, art is any piece of work created by an artist which is passionate about their craft and which is well thought out and skillfully designed to convey important ideas, feelings, or emotions. So, interestingly, even after going on that tangent, right? Even after taking a look at all those concepts, we're still heavily impacted by the established norm in our industry that some areas of our development process are more artistic than others. And it is this way of thinking that is accountable for our natural and almost subconscious categorization of the people and the teams that we come across in our careers. And this is the exact way of thinking that I hope to challenge today. Of course, this isn't me telling you off personally. It's not a problem of the individual as much as a general short-sightedness from a cultural point of view. And this perspective that I bring to you today is not one that I was born with. I mean, in my first few years of game development, I saw the different disciplines around me in a form of like a scale or a spectrum. On one side, you had the artists, right? You had the guys who were responsible for bringing beauty to the world. It was amazing. It was gorgeous. And on the other side, well, you had the not so artistic guys, right? Now, back then as a coder, you could call me whatever you want. You could call me tall, and I'd probably believe you. You could call me handsome, and I'd probably agree with you. But call me artistic, and I would just break into a hysterical laughter. That's the last adjective you could put on me, right? The way I saw it, on that very, very, very far side, you had your artists, your traditional artists. That's your concept artists, right? Your 3D modelers, your animators, your UI, your sound, and all of that great stuff. Maybe towards the middle of the spectrum, you maybe had the designers, right? Still kind of artistic. You have your level designers, you have your game designers, your economists, and so on. Closely followed was your HR manager, right? Coming in there, quite artistic still, has to have some good conversations. Yep, that's you, Brett, I see you, yep. Then the odd fellow that came into the work to fix your fridge, right? Steve from maintenance. Not too closely followed by the office dog. And then so far off the spectrum that you could hardly make it on was us, the coders, the guys who are good with numbers and excel at awkward conversations. That's where we were. So, don't get me wrong, I love what I did, and I still do. I still see the value that we bring as developers. And I don't think we're any less or more important than any of the other disciplines that we're neighbored by. But I just would have never considered my craft one that would be considered artistic. So in one way or another, I wouldn't be surprised if many of us here today have seen things in this way, at least at some points of our career. And the issue with this point of view is that it not only affects the way we see ourselves and the work we do, but also drives the qualities that we look for in those performing these tasks, right? So on the artistic side of the spectrum, we tend to look for creativity, attention to detail, curiosity, and so on. And on the other side, over this way, we place a lot more emphasis on structure, logical thinking, and problem solving. But you see, a painter begins with a blank canvas and uses their expertise and knowledge to create something magnificent. Do we as developers also not possess the ability to create things out of nothing, to bring things to life with our code? NZGDC, what if there is less of a difference between our crafts after all? What if an excellent developer doesn't only need to be logical, but also creative and curious too? What if we, from individual to workplace to industry, could adjust the lens through which we see our craft in order to see code as the logical representation of art? Now you're probably thinking to yourself, man, this guy asks a lot of questions, eh? And you would be right, but they're my love language, so please bear with me. Allow me to hit you with a couple more. And that is, but why? Why disturb the waters? Why come all the way down to Wellington, to NZGDC, just to challenge the common perception and prompt ourselves to perhaps shift our mindset? And better yet, why add a talk about programming? Well, you see, seeing what we do differently, it's not just about sticking a label on ourselves and feeling really good. Oh, we're artistic, yay. It actually also shifts our perspectives and allows us to start tackling the problems that we face each day a little differently. And in doing so, we can greatly benefit our professional career. Oh, look at this guy, you're a legend. Thank you, man. So how does it benefit our, how does the new perspectives benefit us? Well, it makes our development more efficient, right? So because our mind shift has changed to no longer get something done, but rather creating something that is worth admiring, we naturally gravitate to create solutions which are easier to change, reuse, and expand upon, we also reduce the error proneness and error frequency of our code. So writing code in a thoughtful way not only reduces the bugs that we can make, but ultimately reduces our exposure to creating those future bugs. So it's basically a safeguard for us as we go forward. Another important one, it catalyzes our professional growth. As we begin to see the beauty in what we can create, we inherently gain more interest in getting to know the tools that are available to us and how to use them as effectively as possible. These are things like coding principles and architectural patterns and so on. And this sparks a huge hunger for self-improvement and expedites our professional journey. And lastly, it increases our enjoyment. So when we open our eyes to see just how much beauty we can be embedded in a piece of code that we write, and just how many possibilities and ways of solving problems there are, it changes our perspective completely. For example, let's let me give you a non-coding example, right? So let's talk about cooking. Say you had a straight level 1 cooking, you've never heard of it, you've never done anything to do with fire and food, and and then suddenly I asked you to cook an egg, right? Well, you'd be like, okay, whatever, I grab the egg, I put it in the fire, take it out when it looks half done, and we're done, right? Nothing very exciting. But then I come back and I show you about different spices and different cooking utensils and different methods of cooking, and also what pairing options you can use. And suddenly, your world just got a whole lot more exciting. Your possibilities are now endless, and now you're equipped to make a world-class omelet, right? So in the same way, when we put these ideas to practice, the work we do each day becomes more interesting, more challenging, but also more enjoyable. And this brings us to part 3 of today's talk, the more technical side of things, and what that looks like, and what the tools that we can use to achieve something like that. When we look at a piece of code, from anything as narrow and specific to a single system, all the way up to a complete code base, there are some key characteristics that we should really be striving for. The first one is to have extensible code, and that is code that can be modified, interacted with, added to, and manipulated, all without modifying the underlying core functionality. The next characteristics that we look for is for it to be modular and reusable. So creating separated and decoupled systems so that we can basically reuse our code as much as we can throughout our code base, both within our projects, right, but also across multiple projects too. And lastly, and my personal favorite, artistic code forces good practice. It is written in a way where breaking the contracts that we make, breaking the architecture that we set up, is not only discouraged, but it's outright impossible. So these are the things that we should be striving for, and things to consider when we're laying out the foundations of our projects, right? And to achieve these, we as developers have a collection of tools at our disposal. But just like with anything else, there's no one-size-fits-all tool that you can just apply globally, right? And part of what makes us great developers is knowing which tools to use in which scenarios. So for today's illustration, I'm going to be diving into a really typical scenario in our game dev world. The scenario and our goal for the next 25 or so minutes is something that it's really important to get right, but it's often overlooked, and that is the separation of logic and view. So you see, for too long now, have these two been getting a little bit too intimate, and just like a concerned parent chaperoning their kid on their first date, we're going to come in to make sure that they keep their hands off each other. So we're going to work through this together. Now, separating logic and view is a matter of life and death. Dramatic pause. Well, no, it's not really, but not literally at least, but it is the example that we're going to be working through today. And so hopefully at the end, we have something, as I said, extensible, modular, and that forces good practice too. So let's journey together. Let's set the scene, all right? We're all here, busy working on our next top tier secret project, bound to break all sorts of gaming records, by the way. This is going to be a juicy one, right? And in this title, we have a character who runs around the world, slaying their foes, chatting with NPCs, and also offering to trim rune armor in Lumbridge. So that's all well and good. Now, in some gravity-defying way, a health bar floats above our hero, representing the current amount of hit points that he has. As you would expect, when our hero takes damage, the health bar appropriately updates to reflect these changes. And when our hero receives a fatal blow, the health bar shows the 0 hit points, and a death screen also appears to notify us of the terrible, terrible tragedy that has taken place. Don't worry though, I'm sure he's going to respawn at the nearest fireplace. So, first implementations. As coders, let's think. What would be the first way we look to tackle this? Well, it'll probably look something like this. We start by creating a health controller, which is in charge of maintaining our hero's health. Can you guys see that all right? Kind of, eh? Okay. I'll kind of talk through it if it's a bit unclear. Sorry about that. Sorry, where was I? Yes. So we create a health controller, which is in charge of maintaining our hero's health. Within this class, we have a reference to the health bar and our game over screen, of course, right? And we have a take damage function, and when our hero takes damage from any source within this function, we can do all the operations. So we'll go and decrease the current health, and then tell the health bar to update, and if the current health is less or equal to 0, we also tell the dev screen to go and do its thing, right? The thing in this setup, our established contract is that the game's logic knows or references the view, right? So far the health bar and the death screen. And especially early in our careers, it's not hard to see why we might lean to an approach like this. In a way, it kind of makes sense to have the logical flow of operations in a single contained place. I mean, it's easy to read and follow. You go, decrease the health, update the UI, show the dev screen, right? It makes sense. So we're done. Commit, push, mark the task is done, and let's get out of here. Well, not so fast. What we have here, unfortunately, is not a very good solution because it doesn't adhere to those three qualities that we set out to achieve. It's not extensible, it's not modular, and it's also not reusable. And while doing something like this may look relatively okay for now, committing to an approach like this was really going to harm us and our project in the long run as our complexity grows and time goes on. But don't just take my word for it. Let's actually work through together and see where we might run into problems and how. So the first one is building up. Let's take a look at the scenario where our project grows and we're tasked with adding some more view type components, if you will, to the existing system. So now on top of the health bar and the dev screen, as we started, we also have been asked to trigger some animations and some sound effects when certain things happen. In this case, when we take damage, we're going to play an animation, right? So our character takes the hit, right? And we're also going to play some sound effects. There's the sound effects there. And then, and so all good, right? Well, in order to implement that, right, we'll firstly need to grab the reference to the new view components, the animator, the sound effects, and then our health controller's take damage method needs to be completely updated to include the logic around which functions to trigger and when. So in this case, as I said, we play the damage, we play the animation and the sound effect and so on. We're good. And you may still be thinking, yes, so what? That makes sense, right? Well, bear with me. We're still in a relatively simple example. So let's spice things up a little bit. Let's take it up just a notch. So now our project has grown even more in complexity, and now if our hero takes damage, if it's critical damage, we play a specific critical sound effect. Otherwise, we play the regular sound effect, right? And then on the animation side of things, we still play our damage animation on every hit. We also play the death animation when we die. But if our health is less than 3 and we still haven't died, then we also play this like sluggish, weak animation, right? So from the point we started to now, we went from 4 lines of code to this. Our health controller not only has to reference each one of these components, but for each one of them, it has to contain the logic behind when to trigger their functionality. And our health controller class, in turn, is becoming more and more complicated and in turn more difficult to follow. So this is due to something we call code bloat, right? And that is, as the complexity of our peripheral systems is growing, so too is the complexity of our health controller. The other thing we have here is that there is a clear lack of separation of concern. So as more view components are added or as that complexity grows, our health controller is becoming less and less about controlling health, which is the whole point of the health controller, right? So you can see this is not a very extensible solution. We're going to run into problems, and we're only 4 components in. Imagine when you have a collection of view type components which are trying to do its thing. You would end up having with a huge health controller. But let's take this one more step further and look at the reverse. What if instead of building up, we look at breaking down? So what if instead of adding new peripherals, we went the other way around and we were trying to strip out certain view components when we're making a build? And you might be asking, well, hold on, David, when will I ever need to do that? I'm always going to have animations and dev screens and sounds and so on. And which situation would I find myself in which I don't need to have those? Well, actually, there's a few. For example, if your game is a multiplayer game and you're having a server run this logic, right? You most definitely need the server to know about the health being controlled. But the server has no use for the UI and the audio and all those things, and for performance reasons, you're probably going to want to strip that out anyway, right? Another scenario where you probably want to have the core logic without any of the view stuff is perhaps if you're trying to gather data. So say your design team is looking to simulate 10,000, 1 million battles to gather some data around and some averages around what's too strong and needs a bit of a nerf. Now, you can tell Riot doesn't do this because I've played League of Legends for 10 years and patch after patch after patch, Fiora continues to be overpowered. Just kidding, Riot, please hire me. Now, if our logic is tied to the view, simulating 1 million battles is going to have a much higher overhead and ultimately increases the time for us to get those averages, right? And now for one more time, and since we're nearing Halloween, I'll give you a spooky one. Unit testing. I know. It too gives me the heebie-jeebies. For game developers, unit tests are like that gym membership that you know is right there and you should be using, but you kind of just turn a blind eye to. That's unit tests for us, right? The reality is, though, unit tests and testing in general within game development only got that infamous reputation for games where the core game loop is heavily tied around the physics, the timing, and the collisions, and so on. But for games like turn-based battle simulators and things like that, where we can completely abstract the logic out, there's no reason why we couldn't modularize the logic and test it independently. So with that in mind, you can see that our tight coupling has meant that we're not only going to have a pretty hard time stripping out all of these, unless we're happy to add countless if statements in every line where we reference one of these view components, and we're not doing that, let me tell you right now. And the other issue that we have here is that our code is not environmentally friendly. And by that I mean we can't reuse or recycle this in any of our in other areas of our game or in other projects without having to bring across all these other view components which may not apply. And I don't know about you, but I didn't get told to be a tidy Kiwi thousands of times growing up just to throw it all away. So we need to do something about this. Our health controller is not extensible. Now we've seen that it's not reusable. So what do? How do we turn this around before it's too late? Well, I'm glad you asked. Because today, I want to present to you the hero we need but possibly do not deserve, and its name is modularity. And just to clarify, it's not that gecko down there. When we say that something is modular, what we're effectively saying is that it consists of separate parts that, when combined, form a complete whole. And creating modularity within our systems and codebase applies very much in the same way. It is the action of breaking up, packaging, and maintaining our code into distinct systems that overlap in functionality as little as possible. What this looks like visually, and shout out to my friend Gareth here for these awesome diagrams. In a highly coupled scenario, you have the situation where everything talks to everything, right? There's no structure about the lines of communication between different entities and different systems, right? And so it's very hard to move any of these particular systems across to anywhere else without bringing everything else across with it or doing some serious patchwork. With the use of modularity, however, we can achieve a loosely coupled system architecture where the lines of communication are few, specific, and very clearly defined. And in this format, changes in our code do not ripple across our entire code base. So for example, imagine you build a health controller in a way which it could work for your hero today, but it can also be reused for your NPC or your enemy, right? And it doesn't need a dev screen because it's decoupled, right? So we can just kind of slot it here and slot it there. Or better yet, think of the scenario where you have build a health controller for this project that you're working on, and then you're making another project which also has health, and you can just slot it right in. And it could be a text-based game and it still works, right? It doesn't need to have animations or sound or any of that stuff. So that's what we should be striving for. Now, of course, health, is a very small system, but you get the concept, right? You get where I'm going with this sort of thing. So, and whether or not we plan to do this whole, slotting in and out, we should still strive to create systems in this way. And this can be done in several ways and by leveraging a range of a handful design patterns and methodologies. But the one we're going to be looking at today is using the observer pattern. So in order to help me paint a picture today of what we currently have versus what we can achieve using the observer pattern, let's dive into a little bit of a metaphor. Let's say that we're in a factory type environment, right? Where we have a control room responsible for coordinating and communicating with a whole bunch of sectors, such as, maybe the engine room, or maybe you have the workshop, and maybe the research station, right? Now, if our health controller in our example represents this control room at the top here, with our current setup, the control room has a list of all the sectors it needs to communicate with all the sectors as well as it's interested in knowing which things that they might be particularly interested in. So, for example, we know that we need to tell the workshop and the engine room and the research station that they need to all start work. And same thing for break time. But specifically, the engine needs to know about emergencies because it needs to stop the engines and so on. So the control room here needs to know everything, right? It is the brain that drives every operation. The observer pattern effectively reverses this idea. And what it allows you to do is set up a protocol which maps specific messages to specific frequency. So for example, control room could say, by the way, if anyone's interested in start work messages, I'm going to be broadcasting these over frequency 100. And for break time, we're going to be dispatching these over frequency 200. And if anyone's interested, emergencies will be on 500, right? So that's effectively what it looks like. Then each sector is in charge of subscribing to the broadcast frequencies that are important to them. Over at the command room, what's really nice about this is that it has no idea, it has no idea which sectors are listening, if anything. So when a command needs to be sent over the network, right? Perhaps someone is listening, perhaps everyone is listening, maybe nobody's listening. But either way, the command center doesn't care, doesn't bother it, right? So using this exact methodology, we can update our health controller to be the broadcaster of events, if you will, and the view components to be in charge of tuning in as they require. So we can start by creating, it's readable. We can start by creating 2 events, on damage taken and on death. Now, for those of you who haven't run into the event keyword in C#, it basically exposes a subscription mechanism in which other objects can subscribe to. And when an action or a function is marked as event, it also ensures that while the event can be accessed and subscribed to externally from another class, it can't be broadcasted or invoked externally. It has to be internally within the class. So that's to say, for example, the workshop can listen to emergency messages, but it can't broadcast them itself, which is quite nice, right? You don't want your workshop to be saying things over the network that it shouldn't be. So all we need to do now is update our take damage function to simply invoke these events when the hero takes damage or when it dies. And remember, it doesn't care if anyone's listening or who's listening. So moving on to the view components, we simply need to update each one to register to the correct event and handle its logic that's contained within its own class, right? So now, for example, the health bar UI logic is contained within the health bar. So we can see here, for example, we're subscribing to the on damage taken, and we do our own thing, which is update the health bar. Then the death screen subscribes to the on death event, and what does it do? It shows the death bar, the death screen, sorry. The character sound effects subscribes to both, right? It needs to do something when the player dies, which is play the death sound effect. But also when damage is taken, we call this on damage function, which checks if the damage is greater than 5, we play a crit sound effect, and if it's not, we play a normal sound effect. Similarly, for the character animator, same kind of idea, right? And again, I just want to emphasize this idea that now this whole logic around which crit, should I play the crit sound effect or the normal sound effect, that's contained within the character class now, the character sound effect class, should I say, right? So it doesn't leak across all our other components. Our health controller doesn't care, which is really tidy. And we also managed to make all those functions private and within our view classes, which means that we're exposing less code that can be called at the wrong times, which is very nice as well. When we do this, effectively our health controller becomes blind, deaf, and mute in nature. So it's just doing stuff. It doesn't care how that's being represented. And when on top of this, we've also flipped the relationship or that contract that we talked about, where now the view knows about the logic, but not vice versa. This is important because previously we weren't able to just slot our health controller anywhere we liked because it directly referenced all these things, right? But now that that's no longer the case, we're able to package our health controller logic and ship it elsewhere, and where it can be hooked into by a completely different view. And this idea of packaging is actually a nice segue into our last topic of today, because while we have here is really, really great, there's still a concern with the current code as it is. You see, we achieved modularity. We achieved extensibility and reusability, but we're still missing one thing. You see, we have this, I don't know if anyone's noticed, but we have this public take damage function in our health controller, which may need to be called by something, right? Like when we take damage, maybe a trap, when we hit into a trap or a fireball hits us, we need to take some damage. So it makes sense that it's public, right? But we also just said that the view knows about the logic. And so I guess the question is, how do we make sure that a health bar doesn't ever call take damage? I mean, it doesn't make a lot of sense that an animation has the power to ever call the take damage function. So there's still something here that we need to work around. Now, you could argue, if you're the only coder on this project, that you might just remember not to call that function from the view. Or if you work on a team, you might think, well, I'll just code review every commit and make sure nobody does something silly like that. But it's never wise to expose functionality to entities that shouldn't be calling it or shouldn't have the power to call it in the first place, because people can be lazy, right? It's just natural for us to do that. And you can't trust that by simply leaving a comment on a function that people will stop doing the wrong thing, right? As we stated earlier, artistic code forces good practice so that you don't have to. Otherwise, you're either exposing your project to hacky code, or you're creating an overhead for yourself to police this constantly. So this is where I have the privilege of introducing you to our second hero of today, and that is assembly definitions. So assembly definitions, can I get a show of hands? Who knows about assembly definitions? Yeah, a couple, okay, like a quarter, maybe half of the room. Cool. So assembly definitions are Unity assets that can create and organize your script into net assemblies. I'm sure there's an Unreal equivalent. I'm sure there is. I don't know the name though, so I'll ask you guys a question at the end of the talk. There you go. An assembly is a code library that combines all the compiled classes and structures in our project and into essentially a package, right? And we can define references between one package and another. By default, if you don't create any assembly definitions, Unity comes and compiles almost all of your scripts into this predefined assembly, which you may have seen, which is assembly-c#.dll. That is basically any script can essentially see or reference any other script. Now, assemblies are used in our industry, but they're used for a whole bunch of reasons. For example, when you can use assemblies to package your code into modular sections, it makes compile times easier, because when you have a structure like this, whenever you change one file, Unity has to compile everything within that assembly. So a lot of people come into their projects and split out their files so that they can basically speed up the compilation time of their projects. But one of the most powerful things that we can do with assembly definitions, and one of the most underutilized things, is to organize our code in ways that both promote and enforce our architectural design patterns. So by insightfully and cleverly defining assemblies and creating references to other assemblies, we have the ability to reinforce patterns of communication and establish hard contracts between modular entities of our code. That means that at compile time, we can explicitly define which scripts can reference other scripts without us having, to fill our class with comments. This is essentially the infinity gauntlet for game development. It gives us incredible power to structure our code in order to set up foundations that we need for our future development. So let's go back one more time back to our health controller. We can now use what we've learned to make sure that the logic can never reference the view. If we create a view assembly definition and a core assembly definition, and we make the view assembly definition reference the core one, what we're effectively saying is, as far as the health controller knows, if you type in your IDE, let's say health by UI, nothing comes up. It doesn't exist as far as the core assembly is aware. Isn't that beautiful? You don't have to check now. You don't have to code review this. It's just not going to work for anyone who's trying to not have that. And you no longer have to put comments on every single function, or go through your code reviews with a fine-tooth comb to make sure, okay, everything's all good, nobody's breaking anything I set up, which is really, really nice. Now, for the observers among you, you may have noticed that while this is really cool, it still doesn't solve our original problem, which is that we can still call the take damage function from the view, because we reference it, right? So we're heading in the right direction, but we're not quite there just yet. You see, we want to make sure that the view has access to some of the functionality of the health controller, the events, the getter for the current health, but not everything. We don't want the view to ever be able to call take damage. So what we need to do here is, as you probably guess, we need to create an interface, an iHealth controller. And an iHealth controller exposes the functionality that only the view should be aware of. And that way, we still have things like the fireball spell having the access to the concrete implementation to call the take damage. But as far as the view is concerned, the only things it has is on damage taken, on def, and the getter for the current health. So are we done? Well, almost. We just have one little step to go. And that is, when I code, right, I'm always thinking to myself, if someone was, really clever and was trying to mess with this code, what possible things might they try to do to bypass this structure, right? And when I start thinking like that, I go, oh, what if someone grabs from the view, grabs a reference to the iHealth controller and then casts it to a health controller, and then they can still call take damage. I'm like, oh man. So we need to do something about this as well. And I know what you're thinking. This guy has some serious trust issues, and I do. But we've come this far, so let's hit it home, right? Let's hit a home run here. We can create one more assembly definition. Let's say we call it the defines assembly definition, and let's place our iHealth controller interface within this assembly. If we now rearrange our relationships so that core references the defines, because health controller needs to implement iHealth controller, and the view references defines, because that's what exposes the events that we need to have a reference to, we suddenly have achieved a situation where the logic doesn't know about the view, but the view also doesn't know about the logic, at least not directly. It knows about the interfaces that exist. But if you're in the view now and you try go health controller, nothing shows up either. You only have access to an iHealth controller. There's no concrete implementation as far as the view is concerned. So I hope you can appreciate just how much of a win this is. A piece of code like this makes it very, very hard, if not impossible, to break our contracts, to break our structures and the patterns that we set up, regardless of how clever, mischievous someone might be, right? So what do we do now? Well, we step back. We have it. We put down the tools, we look at what we've achieved, and we take it all in. We look at where we started versus what we've got now. A beautiful piece of art, if you don't mind me saying. A system which is modular and scalable in structure, whilst additionally enforcing good patterns, which means less opportunities for hacky code to enter your code base and less work for you to make sure that that's always the case. And this is only one system. This is only one. What if we could think this way from the very start of our projects? What if we could set up foundations like this on day one? Suddenly, there's a place for everything, and everything is in its place. And once we've achieved that, it makes it so straightforward to add new complexity into our projects. Then we reduce the risk of possible errors. We spark an interest and love for architectural design and patterns. And most of all, we're enjoying what we're doing way more. And every challenge becomes a new and interesting problem to solve. We're no longer just spitting out lines of code. We're putting thought into each system. We're being intentional about what we're looking to invoke on the other side, fueled by a passion for software engineering and architecture. Out of nothing, we created something to behold. So NZGDC, can I get a show of hands who in this room considers themselves an artist? Excellent. Thank you very much. Thank you for listening, everyone.
Question? Got a few. Okay, we'll start over.
Hey, excellent talk. Thank you very much. I was wondering how this relates to, like, would you use these sort of setups with rapid prototyping?
Great question. So last year I did a talk about rapid prototyping, and I guess the quick answer would be no. And rapid prototyping, this takes a lot of time to think and a lot of time to construct, and you have to have a very big picture idea. And at the stage of rapid prototyping, you don't even know if you're going to keep this functionality. So I would suggest, no, you don't do this. Once it's locked in that you want to go ahead and you want to craft this out, then it's a time to throw away everything you've got, take a step back, see everything that you need to do in a big picture, and start looking at how you can implement these patterns of architecture, essentially. All good.
Hey, very inspiring talk. It's always great to get more software design into game development.
Absolutely.
Anyway, my question was, why would you use the observer pattern when you could just make lots of interfaces, like say health bar, and make an interface and then make a health bar implementation, and maybe like take damage implementation and different implementations rather than sending messages to multiple places?
Yeah, I guess, well, the first thing I'd say is you can use events, you don't have to. It's quite an elegant way of doing things where you have a one-to-many relationship, where you're broadcasting messages that maybe multiple things need to listen to. As you say, otherwise you're creating multiple interfaces and multiple implementations of those interfaces, right? So the broadcast idea is quite nice for those situations where you're like, maybe a lot of things need to know that the character has taken damage. Whereas if it's a one-to-one, then maybe you turn to a more of, like, as you say, an interface or more of a direct reference in some ways or another. But yes, there's a handful of tools at your disposal. And as I said, there is no like correct answer for everything. It really depends on the context of what you're making and what you're building, and also of the future, being able to future proof. So even if right now there's a single reference to it, or you only need to know about it in a single place, if you can, part of what we can do as experienced developers is kind of look into the future, look into the glass ball and be like, yeah, but I can see this changing, and there's going to be things that are going to need to know about this. And so in that case, you can build it out from the ground up in this way.
So as a developer, one of the conversations I've had is around ugly code and beautiful code, and the ability to engage your emotional sense as to looking at code and just feeling that it's ugly, right?
Yeah.
So it's not a logical thing, it's an instinct that you have.
Absolutely.
And I treat that as kind of like wine appreciation, right? When you first try it, it all just tastes bitter. But then over time and experience and code reviews, you learn to take that emotional response and use that as part of your coding standard.
Yes.
So as part of code reviews, how do you develop art appreciation? How do you develop that emotional instinct in code reviews where you're not just reviewing the detail, you're actually trying to instill that ability to see the overall beauty of the art?
That's a really, really good question. And it's not easy, I will say. It takes a long time, and I would say it's something that you need to build into your teams early on. It's very hard to backtrack, especially when there's a project already or a product already being built, right? I've seen it work really well and not so well in different projects. And basically it all came down to having that intentionality for the design and the architecture from day one, right? So we had the leads were well equipped to know what they want, what the bigger picture was, right? And then from that, they could set up, they had an idea of where things needed, the contracts that needed to be in place, the protocols of communication between different entities. That made it really easy to come in as a project to come into, where the code reviews were happening frequently enough and intentionally enough to make sure that we all very quickly kind of jumped on board, and we're like, okay, that's the way, that's the way we do it. And each time it became a little bit easier and easier and easier, right? Because everybody's it's not just about correction, but everybody starts growing as a team. And that's a really powerful thing about this as well, is that your teams overall are growing together, right? And I think that comes down ultimately to good leadership and a sound understanding of the scope of the project from very early. So it's not always easy to do, right? You can't always tell how big your project's going to be, and we're all game developers. We all know that it starts like this, and then you're 1 year deep, and it's a huge project, right? But I think with experience, we start questioning those things, like, I feel like that's going to grow, and so on. So hopefully that answers the question. It's not easy, but definitely get in early and be intentional. And I would say, as a lead, if you're a lead, and you have a team underneath you, I would say be very intentional about not just correcting, because it's like you don't just want to be like, oh, this is how you do it and whatever. I think the best thing you can do as a lead is to grow your staff and the team underneath you. Try to inspire and to help them see why they might want to achieve these things, and you'll see that it sparks a growth within themselves, right? They start wanting to learn more and know why and understand why these things, rather than just like, oh, there's all these rules I need to apply to my project. That's so annoying, right? So, yeah.
How would you suggest balancing modularizing your code versus the readability of it? Because if you do modularize it, now your source code is potentially scattered across certain places. You have avoided the highly coupled system, but now to someone reading the code, it appears more complicated just to read.
Yeah. I guess it depends just how modular you've made it, right? So it's a case-by-case scenario. I would say when you have a very modular system, it's like there's a big like spike, and like when someone joins, it's like, oh, what's going on? There's so many modular systems. But after that, as I said, once they've kind of jump on board, it's very, very easy to know where things go. It's like you're almost saying, yeah, it might be a bit overwhelming if you come into this room and I say, hey man, there's these 20 boxes, right? So put your glasses on this box and put your jumper here and whatever. And then you're like, oh my gosh, what? But once you understand that, future development is much easier. You straight away, you see something, oh, I can put this on my head, it goes in this box straight away. There's no questioning, there's not much to think about really, because those patterns have been in place. So yeah, I mean, hopefully that answers it really depends. And then on top of that, it's like a cost, right? It's like a cost versus, and on the long run, it's actually quite a lot easier, right? There might be an overhead at the start, but once they're on board, it flows really, really well. I've seen it done very, very well, and it makes development really enjoyable. Yeah. Awesome. Well, thank you very much, everyone. If you have any more other questions, please come find me. I'd love to have a chat. And yeah, we'll talk soon.